Hello again. For those of you who have ever done any woodworking, you've likely encountered wood movement due to seasonal changes in relative humidity. Given this knowledge, have you ever wondered how wood that expands and contracts can be used to build liquid-tight coopered vessels? Well, in today's installment of Traditional Cooperage, we're going to discuss the significance of using quarter riven material and how it defends against this movement, and then I'll demonstrate the quarter riving process. Before we attack this white oak billet with the froe and the maul, let's talk about why quarter riving is so important to traditional cooperage. We put a lot of work into preparing our staves for our cask and then place the raised cask over the fire to truss it into its curved shape. As we drive the truss hoops down past the bilge or the belly of the cask, we hear a gut-wrenching crack, and now we have a broken stave. In cooper's parlance, this is called a duck. This stave failure was due to grain runout because we use quarter sawn wood rather than quarter riven. Grain runout is caused by variations in the wood grain, and the saw doesn't care about grain direction. It just follows the path controlled by the sawyer. With quarter riving, the wood fibers run the entire length of the stave. There are two benefits to this. First is strength, as we won't run into any potential short grain situations like the one that led to our cracked stave. And secondly, by not having any exposed end grain in the length of our stave, the contents of our cask do not have a path to follow through the stave to leak out the ends of the cask. To truly appreciate quarter riving, one must understand wood's properties. It's not just about splitting, it's about respecting the wood's natural patterns. Seasonal changes in relative humidity cause wood to expand and contract in its width. By quarter sawing, we're taking radial slices out of the tree, from the pith or the center of the tree to the bark, so that the growth rings are perpendicular to the board's width. This produces very stable material for building furniture, as the wood is most dimensionally stable in its radial plane. The problem with quarter sawing, as previously stated, is that it often produces grain runout. This is where quarter riving comes into play. We're taking that same radial plane out of the tree, yet we're splitting the wood fibers with the grain. Quarter riven material is what quarter sawn wood wished it could be. With quarter riving, we have a stave length that's dimensionally stable in its width, and we're taking full advantage of the strength the wood has to offer. This dimensional stability allows us to produce coopered vessels that are less likely to shrink, causing the hoops to loosen and fall off. Of course, we still need to start with wood that's sufficiently dry to begin with. This is why the white oak stave blanks at Dill's Tavern are being allowed to dry for a minimum of 2 years before we work them into finished staves. We'll start by splitting off the pith or the center of the tree. There's a lot of intertwined grain here, and it's just going to make our life miserable when we go to quarter split or quarter rive the stave blanks out of this billet later on. So here I'm quarter splitting, quarter riving stave blanks for a bucket or a pail. These are only 11 to 12 inches in length. Imagine how labor intensive this could get if we were splitting this material for casks. So this is a labor intensive job. It would typically be handled by an apprentice in a traditional cooperage, whereas the master cooper would handle more refined tasks such as joining staves. Once we have that gnarly pith out of the way, we can go ahead, split our billet in half, and commence with making those radial plane quarter splits to rive off our stave blanks. We start by setting in, which is to rest the froze blade on the corner of the billet's end grain and start driving down with the maul and continue driving until the froe is embedded in the entire width of the billet's end grain. Once the blade is fully embedded within the billet, we can use the froze handle as a lever to twist the stout blade and force the split. Here we see some remnants of the pith and how that interlocking grain prevents the billet from cleanly splitting along its entire length. So this split's being a little bit cantankerous, and these small billets are too short to use with a riving brake. And so what I'm doing here is using my body as a brake. I exert multiple points of pressure along the length and then use the tool's leverage to easily split the stay blanks. Here I'm making a tangential split and riving off the sapwood, which is just going to be waste product. This white oak stay blank will need to air dry for a minimum of 2 years. And it's no sense in drying any more material than what we have to, and so I'm riving off the pith edge of the blank. Check out those gorgeous medullary rays, which are so typical of quarter riven and quarter sawn white oak. Each stay blank, carefully riven, brings us one step closer to a vessel that will remain liquid tight, whether it's for the hauling of mop water or for the aging and transport of fermented and distilled beverages. Today we talked about the importance and process of quarter riving stay blanks. If you found this video intriguing, please make sure to subscribe to this channel and to like and share this video. Finally, please let a comment and let me know what other questions you have about traditional cooperage. Thanks.